Video for Unit 4, review number 2. So we're given a polynomial and we want to use the rational root theorem to figure it out. So it is all the factors of 84 over all the factors of 5. So 84 is all of these, 84, 42, 28, 21, 14. It's all of those options divided by the factors of the lead coefficient, which is just 5. So it's just 5 times 1. All the p's over all the q's and the plus or minus version of all of those things. You can write it like this on the test, or you could write them all out if you wanted to. Okay, so find all the other factors and zeros. And again, hint, -2 first. So you can see -2 is one of the options. It's right here, plus or minus 2. And basically, we're just telling you that -2 is one of them. So go ahead and start with one of those. Do synthetic division right here, negative 2 on that. And from there, we get this. We can show that -2 is, in fact, a root by showing it's a 0. So we know x plus 2 is a factor. And what we're left with is this 5x to the 4th, no cubes, -27x squared minus 42. And from here, over this guy right here, we just double bubble. Okay, we double bubble this in here and here. And you're like, oh, look at that. Okay, so I know from the first one, x plus 2, I got x squared minus 7. And I got this guy. Those are the factors, and that's in factored form. Now, as far as the zeros, this is going to give you a 0 of -2. This is going to give you a 0 of plus or minus square root of 7. And then this guy is going to give you plus or minus square root of 6 over 5, I. Now, again, you're going to use square roots to actually find that. The y-intercept is 0, -84. And you know it's x to the 5th, so it's got this general shape of up, down with some humps. The details of the humps are all about the x-intercepts. In this case, there are only 3 real x-intercepts, -2, negative square root of 7, and positive square root of 7, and 2 imaginary. So we know it's only going to go 3 times. Even though it's a degree 5, there are 5 zeros, but there are only 3 real ones. So up, down, squiggle, up. And so it still looks like x to the 5th. It's got 3 real solutions, 2 imaginary solutions, and the y-intercept is -84. Okay, this is the same thing, except it's positive x to the 4th, so it's going to look like a w. The rational root theorem says all the factors of 6 divided by all the factors of 1, which really just leaves you that. We say, hey, why don't you try 1 first, which means 1 is a 0. It means x minus 1 is a factor. So do synthetic division by using the coefficients up here, making sure that this is in the right order, 4th, cubes, squares, x's, numbers, and we didn't skip anything. So chuck those in, do synthetic division, and we're left with x cubed plus 2x squared minus 3x minus 6. You're like, oh, look at that, 4 terms. I bet I can factor by grouping. So factor in x squared from the first 2, factor in -3 from the second 2, and all of a sudden you get this. So now we know x minus 1 from here, x plus 2 from there, and x squared minus 3 from the grouping. Now, those are the factors. Now we need to know zeros. -2, 1, and then plus or minus square root of 3. Plus or minus square root of 3 is really close to 1.73. So plot all those. -2, -1.73, 1, 1.73, and then do your graph, knowing that the y-intercept is right there. It's plus 6. And then again, the end behavior, we know that it goes up here and up here because that's what a positive lead coefficient, x to the 4th, looks like. All right, this one. All right, how many real and imaginaries does this have? Boom, right there, x to the 4th. We know it's got 4. Could be 2 real, 2 imaginary. Could be 4 imaginary. Could be 4 real, but that's the only options. And if you look at the graph, we know -3 is 1. So let's just start there. Start with -3, use synthetic division to break this down. You get something like this, you factor by grouping, and then you know that this one gives you 2/3, and then this one gives you plus or minus 2i. And you can see -3, 2/3, and there are no other real x-intercepts because the other 2 happen to be imaginary. You know the y-intercept is -24, so go down there and look, 0, -24, and it follows the general shape. Now, there's not like 2 other humps in there like there is up here in the pink, and that's just this particular version of x to the 4th doesn't have it. This is just asking you understand how irrational roots and complex roots work. Remember, if 3 minus 7i is a solution, then 3 plus 7i is as well. Square root of 5, then minus square root of 5 is. They always come in pairs. Same thing over here. X minus, if 7 is a solution, x minus 7 is a factor. 3i goes with negative 3i. If you multiply those out, you get x squared plus 9. And again, this should make sense that that guy right there has solutions, 3i and minus 3i. If you want it in standard form, we'll just multiply it out. Take your time, combine like terms. All right, here's a graph. Again, you know the zeros. Here, 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 you know, mins here, you know, max here, the y-intercept is 1, and then decreasing, it's going to go down from negative infinity to negative 3, and then go down from like negative 3.93 all the way to infinity. And then it's only going to go up from here to here. It's going to go up from the min up to the max. So mins and maxes, increasing and decreasing, zeros and y-intercepts. All right, long division, right? X minus 1 in front, order it, make sure if anything is skipped, you account for it. And this is the long division process and work. And this one, there is a remainder of 9, which would mean x minus 1 is not a factor, which means 1 comma 0 is not an x-intercept. Same thing here. Doesn't look like, oh, there is one. See how there's no x's there? So we did to make sure we skipped, we accounted for it. And look right there, we accounted for 0 x's. Go through the process. And you get some crazy remainder, and it's just that thing over the divisor. Last one. Okay, this is synthetic. So if the factor is x plus 5, we do a minus 5 as the root. Do synthetic, we get a remainder of 10, which means x plus 5 is not a factor, and there's some remainder 10 over x plus 5. And then this is classic factoring, right? This is move the 45 over and then double bubble. And then we can continue to factor when we get x squared minus 9 right here to x minus 3, x plus 3. Here we're going to move this 50 over, and we're going to factor out a greatest common factor first. And then we're like, oh, look at that. It left a difference of squares. 9x squared minus 25, square minus square. So we get 3x minus 5, 3x plus 5. This is going to be sum of cubes. 125, x cubed is a cube, 8's a cube. So do our sum of cubes formula. The hard part here is that when we're done, we still have to solve, right? Factor and solve. So we factor them, but then we still have to get the solutions. Here we're going to have to do square roots. Here we're like, oh man, we're going to have to do the quadratic formula. We want to know when that's equal to 0. So just use the quadratic formula on that guy. Minus b plus or minus b squared minus 4ac all over 2a, and then simplify. So here are the factors, but here are the solutions. Okay, same thing over here, except there are 4 terms, so you know it's factored by grouping. This is an easy one where it's just minus 2, and then this one you're going to use square roots and get, looks like, I think that's supposed to be a 2 right there, actually. So it's 2 minus 3, 2x minus 3, 2x plus 3, and the solutions are then plus or minus 3 halves. Plus or minus 3 halves. So that's a 2 there. Okay, that's the second review. Again, it's got a lot of stuff on it. It's got factoring, solving, quadratic formula, sum and difference of cubes, difference of squares, imaginary solutions, irrational solutions, long division, synthetic division, increasing, decreasing, maxes and mins, pair, complex numbers and irrational numbers come in pairs, finding a function in zeros from a graph, or maybe I'd just give you one to get you started, and definitely using the rational root theorem to talk to me about all the possible rational roots. Okay, hopefully this helps.